In this video, we'll discuss mill process planning with imported CAD data. After completing this step, you'll be able to create comments, navigate to the manufacturer workspace, and identify toolpaths. In Fusion 360, we want to begin by uploading a supplied dataset, CAD-CAM dataset1 process planning.iges. An IGES file is a neutral or an intermediate CAD format. Once you upload it, there will be a slight amount of processing that has to happen to convert it to a Fusion file. Once it's ready to open, you can simply double-click on it to open it up inside of your canvas. We're going to go ahead and hide the data panel and take a look at our design. Whenever we're starting a project, there are a couple different ways that we can be given our data. We can either be the designer, modeling the part completely in Fusion 360 and having all of the information needed. We can be provided a detailed drawing in which we need to gather all the critical information and potentially model the design ourselves, or we can be provided a neutral CAD format. When we have a neutral CAD format, there is going to be some metadata that's lost, and generally this will also be provided with a detailed drawing. This will have specifics about tolerance values and critical areas of a design. However, in this case, we're dealing with an imported CAD file, and all we have to go off of is the CAD file itself. When we have a situation like this, we have to make some assumptions, and we need to use the tools that we have available to gather information from the design. The first thing that I want to note is the document settings. The document settings by default are going to be metric. In this case, that works for us because we've already looked at a detailed drawing of this part and we know that all the values were metric. But in some instances, you might use tools like inspect and take a look at certain elements of the design and need to decide whether or not this is an inch or a metric file. Things like a large radius. If it's exactly a metric value, such as 65 millimeters, as opposed to 2.559 inches, this helps us understand whether or not this was designed as a metric file or if it was designed in imperial units. For our purposes, we're going to carry on with the metric units, so I'm going to minimize those document settings. Another thing we'll notice is at the bottom there's no timeline. In order to turn this on, we need to right-click at the top level of our browser, and we need to make sure that we capture design history, which is all the way at the bottom. Whenever we're dealing with a neutral or an imported CAD file, by default, time capture or the history will be turned off. So if you're going to make any adjustments or changes to the design, make sure you turn that on. It's also important to note the orientation of the part. Right now it's in the Y up orientation, and you'll notice that our top is in the Z orientation. So if I hit home, it's going to flip it around to an orientation that is not ideal for us. There are a few things that we can do to fix this. We can take a look at the corner and simply select this and reset our home, or we can even modify our display. For example, go to this view, use our drop down, and we can set our current view as top. This modifies the view cube, but it keeps our X, Y, and Z orientations the same. This helps us reset our values, but once again, home is not correct, so I'm going to go ahead and use my view cube to get back to a home view, use this drop down to set current view as home. I'm going to do this at fit to view, so now if I rotate my model and select home, everything is viewed as expected. Now that we have our design inside of Fusion 360, we're capturing history and we've modified some of our display settings, let's talk about capturing information from the design itself. The bottom of our browser, we have an area called comments. This allows us to capture text as well as images, and we can use that as specific information about our design. For example, if I want to use inspect and I want to measure the height from this top face down to this face, I can see that it's 25 millimeters. We can zoom in on this, move it around, and we can capture the image. By capturing that image, anytime we come back to this comment, we can see that information. This also helps us understand what size tool we might want to use and how far it needs to stick out of a holder. So in this case, I'm going to simply say contour, which is around the outside, 25 millimeter end mill. I'm going to say 50 millimeter projection. If I reset my selection and I go from this top face all the way to the bottom of the design, you'll see here we have 50 millimeters, and that's going to be the minimum amount we need that tool to stick out. There are other things that we can capture as well, but make sure that you do hit post as soon as you want to capture that comment. We also have the option to comment on a point. If I want to take a specific look at this slot, for example, I can take a look at the value of the corner. The diameter is 5 millimeters. And I can also take a look at the depth. It's 10 millimeters deep. So if I want to comment on this geometry specifically, I can select a point and I can use the comment on a point. In this case, I'm going to say 4 millimeter end mill, and it's going to be 10 millimeters deep for 4x slots. We can post that. And now, whenever we take a look at this, it's going to zoom our view to that specific area. And we click on the comment, and it'll go back to a view of that slot. So once again, this is another way in which we can use these comments to our advantage. So that way it's easy for us to see exactly what we were talking about when we originally created those comments. Another great thing about comments in Fusion 360 is they go along with the design. So if we navigate to the manufacturer workspace, the comments are still here. We can still get the critical notes that we left behind in the design workspace. For now, let's go ahead and minimize our comments. The last thing that I want to do is use inspect, and I want to measure these small holes. You can see here the diameter is 4.234 millimeters, and we can see the area and the loop length, but we don't have a depth. So I'm going to restart the selection. I'm going to go from the top to the bottom and see that we have a 15 millimeter depth. What I want to do from here is I want to capture the fact that that is a tapped hole. So I'm going to say hole 4.2 millimeter drill for an M5 by 0.8 tap. And I'm going to say bottom 15 millimeters. This helps me understand that we're talking about a blind hole. We need to drill it with a 4.2 millimeter drill, and we need to use an M5 by 0.8 tap. So I can post that, and you'll notice that I didn't capture an image and simply just posted it as text. I'm going to close out the inspect tool, and I'm going to minimize my comments. Another thing that we want to note when we're talking about using comments in a design is we haven't had to save the design at all. When we expand our comments, you'll notice that it says V2 at the top of the comment. So you'll get a good idea where we place the comments when we originally created them, which version of the save we were in. Also note that if a design needs to be saved, when we place a comment, it'll automatically save the design for you. So at this point, no save is needed. Let's go ahead and move on to the next step.